All right, everyone get ready, because today we're going to do a deep dive on vanadium.
Sounds good.
You send in a ton of interesting stuff. We've got the Royal Society of Chemistry article, like a whole Wikipedia rabbit hole, even some stuff about the contact process.
Yeah, it seems like you want the full vanadium rundown.
Yeah.
Why it matters, where we find it, all that good stuff.
Yeah, I have to admit, like, before this, vanadium was just kind of like a name on the periodic table to me.
Right.
But now I'm seeing it everywhere. Viking myths, like super strong steel, even sea squirts.
Yeah, it's a pretty versatile element.
Definitely way cooler than high school chemistry, that's for sure.
Well, what I think is really interesting about vanadium is it was actually discovered twice.
Oh, really?
First, by Andrés Manuel de Rio way back in 1801.
Okay.
He found it in this mineral, called it brown lead, even gave it a name, pinchromium.
Pinchromium. Honestly, I kind of like that name. Very dramatic, you know?
Pretty fitting, actually.
Okay.
Vanadium compounds are famous for their crazy color-changing abilities.
Oh, wow.
But unfortunately for Del Rio, people didn't believe his discovery.
Oh, no.
Yeah, he sent like some samples over to Paris, and they thought it was just some kind of chromium.
Oh, that's rough. So close. Okay, so if Del Rio got robbed, how do we end up with the name vanadium?
Well, fast forward like 30 years, and we have Nils Gabriel Säfström, a Swedish chemist this time.
Right.
He isolates vanadium again, but this time it's from iron ore. And his findings actually stuck, thankfully.
Gotcha.
And the name, well, he was just blown away by how vibrant the colors of vanadium compounds are. So he named it after the Norse goddess of beauty, Freya, who's also known as Vanadis.
Wow. Okay, that's a way better story than I was expecting. I'm picturing like Norse mythology, dazzling colors, and some very confused chemists in Paris.
Yeah.
But let's get into like, the practical applications of vanadium. I don't picture Freya hanging out in a blacksmith workshop or anything.
Right.
So how'd vanadium go from this like goddess-inspired element to, something actually useful?
So this is where it gets really cool. Remember those color-changing compounds?
Yeah.
They're not just pretty to look at. They're actually the key to some of vanadium's most important uses.
Oh, interesting.
But the most impactful application is in steelmaking.
Okay, here we go. This is where vanadium gets tough, right? Like super strong alloys and industrial revolution stuff.
Yeah, exactly. If you add even a tiny amount of vanadium to steel, we're talking less than 1%, it completely transforms it.
Wow, okay.
Suddenly you've got a material that can handle like incredible forces. It's resistant to all kinds of shocks and vibrations.
So we're talking like next level toughness here. But this isn't just, modern day skyscrapers and bridges, right?
Yeah.
Didn't you say something about ancient swords?
Oh yeah, Damascus steel.
Yeah, Damascus steel.
Those legendary blades, everyone wanted them for their strength and sharpness.
Right.
But it turns out they were actually, it was actually vanadium that gave them those like almost mythical qualities. Completely by accident.
No way.
Yeah, the iron ore they used just happened to have vanadium in it.
Wow.
And when that source of ore dried up, well, so did their ability to make these swords.
Wow, that's crazy. Talk about a metallurgical mystery. It makes you wonder what other secrets are hidden in the periodic table or, in the ocean, I guess.
Yeah.
You mentioned sea squirts before, and I have to admit, I'm drawing a blank on that one.
So get ready for this, because this one's a real head scratcher. So sea squirts, right? Those little blobby things. They have a superpower.
Okay.
They can concentrate vanadium in their blood to a level millions of times higher than the seawater around them.
Millions. Okay, that sounds less like a superpower and more like a recipe for disaster. Like, how is that even possible?
That's what we want to know. Scientists are still trying to figure out how they do it and, more importantly, why.
So we've got, like, sea squirts hoarding vanadium for some unknown reason. We're over here using it for everything from tools to recreating legendary swords.
Huh.
But you also mentioned a contact process and making acid. That sounds kind of intense, even for vanadium.
It is, in a way. The contact process, it's how we make sulfuric acid.
Okay.
Which is like one of the most important chemicals in like industry, period.
Yeah.
And guess what has a starring role?
I'm guessing. Vanadium.
That's right. Vanadium pentoxide, to be exact. It acts as a catalyst in the process.
Okay, hold on. Just a refresher. For those of us who, haven't taken chemistry in a while, what does it mean for something to be a catalyst?
Basically, a catalyst speeds up a chemical reaction, but it doesn't get used up itself. Think of it like it's a chemical matchmaker.
Oh,
Vanadium is playing Cupid between sulfur and oxygen, helping them make sulfuric acid.
And sulfuric acid is important because...
It's in, like, everything. Fertilizers, detergents, batteries, even explosives, they all need sulfuric acid. It's so important that like the amount of it a country produces is seen as a measure of how strong their industry is.
Wow. I had no idea sulfuric acid was such a big deal. So we've got vanadium quietly running the show behind the scenes, making all this happen. I'm starting to think we take this element for granted.
It's true. And the more we look at vanadium, the more we realize just how versatile and important it is.
Yeah.
But what's even more exciting is like its potential, especially when you look at clean energy.
Clean energy.
Yeah.
All right, now you're speaking my language. So what's vanadium got to do with saving the planet?
Well, remember how we were talking about those different oxidation states, those different like personalities that vanadium can have?
Yeah, it's like the Clark Kent and Superman of elements.
Right, exactly. And it turns out those multiple personalities are like really important when we're talking about renewable energy, specifically something called vanadium redox flow batteries.
Vanadium.
Yeah.
Batteries. Okay, now I'm really interested. You got to tell me more. How do those work?
Okay, so imagine two tanks, right, filled with a liquid electrolyte.
Okay.
And each one has vanadium ions, but in different oxidation states.
Mhm.
Now, these tanks, they're separated by a membrane. And as the battery charges and discharges, these vanadium ions, they move back and forth across the membrane.
Right.
And by switching between those oxidation states, they actually store and release energy.
Wait, so the vanadium itself is like the battery. That's incredible. What's the advantage of that over, like, a normal battery?
There are actually quite a few advantages. Vanadium batteries are super durable. Like you can charge and discharge them thousands of times. They won't wear out like a lithium-ion battery.
Wow.
Plus, they're way safer. They use non-flammable materials, nothing toxic.
So they're like the eco-friendly, super reliable superheroes of the battery world. Okay, I'm sold. But are these actually being used right now, or is this like still science fiction?
Oh, no, they're being used right now. You'll find these vanadium flow batteries in grid-scale energy storage, especially for dealing with the ups and downs of renewables like solar and wind power.
Oh, that makes a lot of sense, right? The sun's not always shining, wind's not always blowing.
Right.
But with these batteries, we can store that energy for when we actually need it.
Exactly. They're like giant energy reservoirs, making renewable energy more reliable, more efficient.
That's amazing.
And the best part is you can just scale them up super easily, just use bigger tanks. It's a really elegant solution.
Okay, I'm convinced vanadium is officially a champion for clean energy as far as I'm concerned. But we've talked about like super strength, making acid, batteries. Is there anything this element can't do?
Well, there are still some mysteries we haven't figured out, especially when you look at the biological side of things.
Okay.
We talked about those sea squirts earlier and how they can handle these insane amounts of vanadium without, well, dying.
Yeah, seriously, it's like something out of a comic book. What are those little guys doing?
Honestly, we don't know. Some researchers think they might be using it for oxygen transport, maybe even as like a defense mechanism, but we need more research to say for sure.
Wow, fascinating. So we've got this element, incredibly useful for all sorts of industrial stuff, and it might hold the key to new biological processes too. It
Yeah.
really makes you wonder. Makes you wonder, like, what else is out there?
Right, yeah.
If sea squirts can, like, unlock some weird vanadium superpower, what about the other elements? It feels like we're just scratching the surface of what's possible,
Yeah, and that's what's so exciting about all this.
Right.
We've learned so much since those early days, those accidental discoveries,
Yeah.
but there's still so much we don't know. Vanadium is like the perfect example of that.
Okay, so we went from, like, Viking goddesses to super steel to clean energy, even, like, potential medical mysteries.
Yeah.
It's kind of mind-blowing how much ground vanadium covers.
It really is.
So for everyone listening who's been on this vanadium journey with us, like, what's the main takeaway here?
I think the biggest thing is vanadium shows us we got to look beyond the obvious,
Okay.
question what we think we know, and always be ready for something unexpected. It's like those incredible discoveries, they often come from the most surprising places.
I love that. It's a good reminder that the world is full of amazing stuff. We just got to look at it the right way to really see it, I guess.
Exactly. And who knows what other secrets vanadium or any of the other elements are hiding. There's a whole universe of possibilities out there.
Well, I know what I'll be thinking about for the rest of the day. This has been an incredible deep dive. Honestly, I don't think I can look at the periodic table the same way again.
It's been a pleasure talking about it.
And for everyone listening, stay curious. We'll see you on the next deep dive.